Hello, welcome. Today we're going to be looking at direct substitution method. Direct substitution method is one of the methods under Laplace domain, and majorly what it does is that it is used actually to determine the limit to which values of gains, derivative, and integral can attain to make a system stable. Whenever you want to determine the limit, very important, limit to which values of gains, derivative, and integrals can actually attain to make a system stable, you use direct substitution method. To obtain these values, first of all, whenever you want to do direct substitution method, you must substitute IW in place of X. So X equal to IW is substituted into the equation. The real and imaginary parts are obtained. The real and imaginary parts obtained are equated to 0 to solve for the values of the parameter. So that's how you do it. Whenever you're given, this is a characteristics equation. Anywhere you see X, replace it with IW. You understand? So when you do it, any part that is containing I is imaginary. The part that is not containing I is the real. So separate them and equate them to 0. Then you solve down. See, it's very, very simple. So let's take an example. With the example, you understand it better. Using the DSM, which is direct substitution method, find the limit of stability of the system whose characteristics equation is given as this. I told us in control, you must always have a characteristics equation. So this is the characteristic equation written in terms of X. You understand? So first thing you do, and you should do it with respect to K. So find this limit with respect to K. And I told us that you use direct substitution method whenever you want to determine the limit to which values of gains, derivatives, and integrals can attain to make a system variable. So to make a system stable. So whenever you are given such equation, you are given this characteristic equation. So first thing you do for the solution, let X be equal to IW. The characteristic equation becomes this. You can see now from this is now what we have as the characteristic equation, because we substitute anywhere we see S, we put IW. So this is IW to power 3 instead of X to power 3 now. Now you have 3 IW to power 2, 3 IW, then 1 plus K equal to 0. But when you're doing this, make sure that whenever you have to power 3, you have to put minus at the back. Very, very important. If you have to power 3 and you are having this, you're having imaginary factor attached to it, make sure you change it to minus. Now you have plus 3 IW, then you have this, then we have this. So bringing this down now, you now have minus IW3 because you have to leave this with this. Then when you have IW squared, for you to remove this I, put 3 in front of it. But whenever you have squared, know that you are changing it to real parts. So this becomes this, taking this out and replacing it with minus. This one you bring it like this because it's still not, this is square. Whenever you have even power, that's when you do this. So bring this down, bring this. So looking at this now, after removing all the brackets, what we did here was to remove the brackets. You can see these brackets here. So remove it, you have this. This is 3 to power 3. This one that is to power 2, remove the I and remove the bracket. Place, instead of, since you remove the I, put negative here. This one just remove it like that. This one bring it. So once you have this has I. All the ones that have I are imaginary. This one has I. This one has I. This one does not have. This one does not. So you take these ones that have I as the imaginary roots. So represented here, removing the I, you have W3 plus 3W equal to 0. Then the ones that don't have W, bring them. Minus 3W squared plus 1 plus K equal to 0. So you equate the two of them to 0. Then you solve down. Now, if you are calling this equation 1 and this one equation 2, from equation 1, from this very equation, you can say that W3, take this one to the other side, my negative cancel negative, you have W3 equal to 3. So that W is equal to plus or minus root 3. But then what you actually need is w squared in this equation to solve out, because there is w squared here. So w squared we found to be 3. Then using equation 3, this very equation, in equation 2, putting it in equation 2. So anywhere you see w squared, you replace it with 3. So that's what we did here. Minus 3 in bracket 3 instead of w squared plus 1 plus k. So make k the subject of the formula, you get k to be equal to 8. So hence, at the limit of stability, k is equal to 8, which is what you are told to find. Find with respect to k the limit of stability, and you found it to be 8. So whenever you're given problem to solve using direct substitution method, always remember that given the characteristic equation, anywhere you see s, replace it with iw. Then solve down, simplify, get the imaginary part one side, equate it to 0, get the real part one side, equate it to 0. Then using simultaneous substitution method, solve down to get what you want. So area of very important concern is that whenever you have 2 power 3, introduce negative and open the bracket. If you have 2 power 2, introduce negative, open up the bracket 2. You understand? So that's how you get this one down, so that you substitute and get your final 8. In subsequent classes, we'll be doing more difficult questions. Thank you. God bless you. Click on subscribe button, share our videos. Thank you.